Okay, question number 9 wants us to show that tan to the 4x can be written as this. Now usually you change the left hand side into the right hand side. So what can we do with the left hand side? The only thing I can think to do with tan to the 4x is write it as tan squared x times itself. Looking at the right hand side, there's sec squared x's. Now we know that sine squared x plus cos squared x equals 1, and if we divide everything by cos squared we get tan squared x plus 1 equals sec squared x. I always have to write that out, I can never remember the order, but we can say that tan squared x is equal to sec squared x minus 1. Do we want to change both? And then multiply out. Let's try that. Let's change them both into sec squared x take 1 and then multiply out the brackets. No, we're going to get a... Oh, that's easier. We just need to change one. Just need to change one of them. So times that by tan squared x, and we're going to get tan squared x, sec squared x, take away tan squared x, and then we can change this tan squared x, keep this one because that's in the answer, minus sec squared x minus 1 again. And then if we expand that little set of brackets at the end there, we're going to get minus sec squared x, and we're going to get a plus 1, and we can change the order. Plus 1 minus sec squared x. Okay, part B then asks us to integrate tan to the 4x. Now obviously we're not going to integrate tan to the 4x, we're going to integrate the thing they've just told us to turn it into. That's always what you have to do on these types of questions. However, that's not the end of the difficulty. We've got a 1 which we can integrate fine. We can integrate sec squared. We can't straight away integrate a sec squared x tan squared x. However, I'm going to do that separately so you can see what I'm doing, but this is one of those times when if you differentiate tan x you get sec squared x. So this is one of those integration by substitution questions where they don't give you the substitution. You let u equal tan x, because watch what happens. Du by dx is equal to sec squared x. That's one of the known derivatives. Dx will then equal du over sec squared x, and this sec squared will cancel with this one. So integrating sec squared x u squared du over sec squared x, and the sec squared x's cancel, and we just need to integrate u squared, which is u to the 3 over 3. U was equal to tan x, so that's tan cubed x over 3. So that is the answer to the integral of this. So the whole thing, if we go back to the blue now, the whole thing is going to integrate to tan cubed x over 3 plus x minus, integrate sec squared, you get tan x. So minus tan x between pi over 4 and 0. Subbing the values in, tan of pi over 4 is 1. So we've got a third plus pi over 4 minus 1. Tan of 0 is 0, so that's minus 0, 0 and 0. So final answer is going to be pi over 4, 1/3 minus 1 is going to be minus 2/3. So that's my final answer.